you are expected to identify the metrics of measurement of anomaly detection algorithm, follow the process of calculating the metrics of measurements, and appreciate the use of the metrics in anomaly detection algorithms. In applying our algorithm, we always ask ourselves, how does the algorithm that we have chosen perform? Because the performance really can affect the choice of the model that we're going to perform for future projects or future data sets. Of course, in the process of this application, you have to make some changes. You have to make some kind of adjustments so as to conform to the new set of data and variables so that you can meet the demand of the business question at hand. So this lesson is actually very important because this will give us the proper understanding of the metrics of measurement that we use for our anomaly detection algorithm. But of course, we have a lot of algorithms, or what I mean is metrics to use for measuring the performance of our anomaly detection algorithm. But so far, these are the most famous ones. So we have precision, we do have recall, and also we have rank power. So we're going to have them one by one. So first, we're going to have precision. What does precision measure? How do we arrive at the conclusion that a certain output given by our algorithm is really performing very much well? How precise is it? So basically, precision answers the question, how many of the data points that were predicted by the model to be anomalous were correctly identified to be anomalous by our model. We can say, for example, that M, okay, it's not working well. So I guess I have to change it. Okay, so we have, for example, M is greater than 0, and this one represents all data points predicted to be anomalous. Or in other words, this is the potential anomalous points. Out of these anomalous points, how many are correctly identified to be anomalous by our algorithm? So having these values, now we can get the precision using this formula. So we have the correctly identified anomalous points. Then we're going to divide that by the total number of data points that were identified by the model to be anomalous. The higher the value would mean that the precision is really higher. So it means that our model is performing very much well. So when the value is 1, it means to say that all points were correctly identified by the model to be true outliers or anomalous. So after this identifying the precision, now we're going to ask ourselves, has the model properly or correctly recalled the outliers or anomalous points? So this question can be answered by this recall. So what is this recall? Recall means how many out of these empty or true outliers the model correctly identified. So basically, we can do that by using this computation. So just like this one, so when the value is equal to 1, then we could say that all true outliers are discovered by the algorithm. But of course, in the real world, this one can be very difficult to arrive at. So for us to be able to properly understand these two metrics, precision and recall, we're going to have this example. So this one concerns the credit card transaction fraud. Our dataset has 1,000 transactions, and out of these 1,000 transactions, we consider 200 to be fraudulent. So how do we get the precision and how do we get the recall? So it's very easy. We just have to plot these values in our formula. So 200. So this one, empty, the ones presumed to be anomalous, and we're going to divide that by 1,000, and that gives us the precision of 20% or just 0.2. So what is the recall? So we've said that the recall is the proportion of the true outliers discovered by the model on top of the suspicious fraudulent transactions. So we have, in this case, 200 divided by 200. and that is equal to 1 or 100%. So this means that our model has perfectly identified all of the data points to be anomalous. But then again, in the real world, this one does not happen. As of this moment, I want to tell you that the precision and recall actually have some kind of problems when it comes to identification because they are actually very much insufficient to completely identify the anomaly points or anomalous points. So in short, we can say that they are not very effective in identifying anomalies. And why do we say this? That using just precision recall does not make our algorithm really effective in identifying anomalies. The reason for this is that, for example, when we have two algorithms used in anomaly detection, the result can give us different numbers of anomalies. So if we're going to look at this one, here in this case, we are using a larger number. And of course, this would give us a small amount. So if we're going to use, for example, two algorithms in a certain situation, for example, in a credit card transaction, one algorithm may identify one outlier to be the most suspicious one, but in another algorithm, this data point may be identified as the least suspicious. Here comes the problem in the use of precision and recall because we also have to remedy this kind of situation. Because not in all cases, we may use the same number of data points. Remember this that we always, or in most cases, we use the 70-30 for the training and the test sets. The remedy that we can offer is the use of rank power. And this rank power can answer the question in the situation that we have just illustrated. So what is this one? So basically, the rank power can be computed using this formula. So we have Ri, which is equal to MT, the number of data points which we have suspected to be anomalous. And what we do is we multiply that to itself, but then we add 1 over 2 and the summation of the Ri. So maybe you would want to ask me, what is this Ri all about? So Ri is actually the rank of the ith outlier in the sorted list of the most suspicious objects. Say, for example, when we have 10 suspicious data points or objects in our data set, so we're going to rank them from 1 to 10, 1 being the most suspicious point, and the 10 being the least suspicious point. So basically what we do here is just we rank the data points which are considered to be anomalous. So for better understanding of this metric, we're going to have this example. So supposing we have 1,000 data points and we have identified 100 data points to be anomalous. So out of these 100, 4 are empties. So what are these 4? So we have data point 1, data point 25, data point 76, and data point 91. So how do we get the precision? It's just very easy, just like the number 1. What we do is we just divide 4, the empty, over 100, or by 100, which is we have the suspicious data points, and that gives us 0.04. So this one is not enough because we have to get the RP then. So what's the RP? Just very easy. We are just going to plug in our values. So we have 4, and 4 plus 1 is 5. So 4 times 5. And we have already identified the positions or the ranks of the suspected or suspicious data points. And the truly outliers are 1, position 1 or rank 1, rank 25, rank 76, and rank 91. So what we do here is just we add them and then we multiply the result by 2. And so we have 30 or 20 divided by the result of this one, and then we get 0.05. And so having this one is actually better than having precision and recall. It's because we consider the ranks of the points which are considered to be the most suspicious and the least suspicious. What is this for? Why do we have to study this? Basically, having the proper understanding of the different metrics of performance or measurement is a great help to identify which algorithm is the best one to use. Apart from these metrics, there are also other metrics to use for us to be able to identify the performance of the algorithms that we are using. After all being said and done, let's try this. What are the metrics of measurement? How do we calculate each of these metrics? Why do we have to know these metrics? Please write your answers in the comment down below so that we would be able to have a very rich interaction of ideas and we can learn from each other. Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free like Machine Learning Essentials, Deep Learning Mathematics, and a lot more. Here, you can always learn an upskill for free.